Welcome to question 9 of the 2011 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 9 we have parts of the graph of the functions f and g are shown on the diagram below, where f of x has a rule that is x cubed minus ax, so that is this graph here, and g of x has a rule ax, and that is shown over here. And we know that for both of these functions, a is greater than 0, so a is positive. We know that the graphs intersect when x is 0 and when x is m, so this point here and this point here are the points of intersection. And we are told that the area of the shaded region is 64. So that means that this shaded area here is 64. And using that information we need to find the value of a and the value of m for this question. So firstly, just out to the side, we're going to think about the point of intersection, and that is when the graph of f of x is equal to the graph of g of x. So using their rules, that is the same as x cubed minus ax is equal to ax. So therefore we can subtract ax from both sides and we get x cubed minus 2ax is equal to 0. And now factorising that, we can take x out as a highest common factor, leaving behind x squared minus 2a is equal to 0. So the null factor law would say x could equal 0, or that x squared minus 2a could equal 0. Now we knew that x equals 0 was a solution, so the other value here must be m. So that gives us that x squared must equal to a. So x must equal plus or minus the square root of 2a. So from our graph we can see that m is greater than 0. So m greater than 0 gives us m is equal to the positive square root of 2a. So therefore the area we know is related to an integral, so it's going to be the integral from 0 to m. So they are the points of intersection between the curves that the area is bounded between. And then we have our upper function, which is the orange function of g of x. So we have ax is its rule, and then we need to subtract away, and in brackets we have the function of f of x, which is the lower curve, which is in purple. So we have minus x cubed minus ax, and that is with respect to x. So therefore our area is going to equal the integral between 0 and m, and we're going to have ax subtract negative ax will actually give 2ax minus x cubed dx. So therefore the area is going to equal, and we find the antiderivative of that, so 2ax will add 1 to the power of x, which will give 2ax squared, and dividing by the new power will just leave ax squared, minus, and then for the second term we add 1 to the power, giving x to the power of 4, and we divide by the new power of 4, and we still go between 0 and m, which are the terminals. So therefore the area, which we know is 64, is going to equal the upper terminal substituted in, which gives am squared minus m to the power of 4 over 4, and then we subtract away from that the lower terminal substituted in for x, but if I put 0 into there we simply get subtract 0. So therefore 64, the area is going to equal am squared minus m to the power of 4 on 4. But from before we know that m is equal to the square root of 2a, or that m squared could be written as equal to 2a. So therefore we find 64 is equal to a times 2a, so that's replacing m squared with 2a, minus, and this can be written as 2a squared, so m squared squared is m to the power of 4 over 4, and now that can be simplified down to 2a squared minus 4a squared over 4. So 2a squared minus just a squared leaves a squared, so therefore 64 is equal to a squared, which will give us a equals plus or minus the square root of 64, but we know that a is greater than 0, which means that a equals 8. So that is one part of the answer to this question. And next we know that m is equal to the square root of 2a, so that's the square root of 2 times 8. So therefore we know m is equal to the square root of 16, which is 4. And that is the second part of this question that we needed to answer. So from the examiner's report we can see that 16% of students got full marks for this question, and that the majority of students could set up a correct integral equation for the area. But only a few students realised the significance of the point of intersection to achieving their final answer. Many students spent time determining the area between two curves by relating all areas back to the x-axis. Instead of using a single definite integral to determine the area, they had 3 definite integrals, or the area of a triangle, and 2 definite integrals, which would have taken much longer to process. Poor use of brackets led to a number of students incorrectly cancelling ax in the integral, and then quickly getting an answer of m equals 4. And finally, some students incorrectly left the point of intersection in terms of x, and substituted this directly into the integral, which would not have helped them progress with the question.